Hi everyone, we are continuing with proportions and we are talking specifically about the golden ratio and the golden rectangle. So first, as a warm-up, we have two problems here. I'd like you to go ahead and pause the video and try to do these yourself before watching. Okay, so to solve this, we're given that the ratio of side lengths of some quadrilateral are 2 to 3 to 5 to 7, and then the perimeter is 85. So all that this tells me is that 2 is to 3, is to 5, is to 7, and the total is 85, meaning x must be 5. Okay, so in order to find the length of each side, I just need to plug 5 into each of these quantities. So that gives me 10, 15, 25, and 35 feet. Okay, next, they say that given 18c is 24d, they want me to find the ratio of d to c. So they're asking me to solve for d to c. Okay, in order to do that, I can divide both sides by c, divide both sides by 24, so I get 18 over 24. So that reduces to 3/4. Okay, so next we are exploring a little bit of what the golden rectangle is. Euclid actually showed this in his book. We talked about that briefly last semester, about the golden ratio. The golden ratio is one of our special irrational numbers like pi and e, and it's represented using the Greek letter phi. And the idea behind the golden ratio is that the ratio between two numbers has to be the same as the ratio between the larger of the two numbers and their sum. Meaning, let's say if a is greater than b, then that means that a is to b as a plus b is to a. Okay, that's what that means. So actually figuring this out, they gave us a square with side length 2 inches. I'd like you to walk through the steps first on your own and see if you can get through this before seeing how I did it. Anytime it says by construction here, you can just use a ruler and measure it out. So go ahead and give this a shot and then rewatch if you run into trouble. Okay, so first thing they ask us to do is find the point M and connect to C. Right, so right here I see that AM has a length of 1, so if I use the Pythagorean theorem, I get a hypotenuse of 5, root 5. Okay, then what they ask us to do is extend AB further, and we'll actually extend this rectangle to this point E, and what we want is for the length of ME to be the same as the length of CM. So what that means is if AM is 1 and ME is root 5, that means that the length of AE must be 1 plus root 5. So if they're asking what the length of segment BE is, that would be root 5 minus 1. Okay, so we end up constructing this. We extend to make our rectangle, and then we want to compare the ratio of AE to AC and FE to EB. So if we do that, we end up getting 1 plus root 5 over 2 and 2 over root 5 minus 1. So converting each of these to a decimal, I get 1.618 and again 1.618. So I end up getting the same thing, which is exactly what I wanted. Okay, let's go through a few examples of how to actually do this. So we have a golden rectangle here, and they want us to find the dimensions of the outer rectangle ABCD. So I'm just going to set up a proportion. I'm going to be using ABCD and relating to my inner rectangle here. So I know that 4 is to x as Again, the longer side here is x is 2, and I need this length right inside here. If this length is x, then this length right here must be 4 minus x. Okay, so if I solve this out, we can cross multiply. I get 16 minus 4x being x squared. Okay, and you can solve this however you want. You can use the quadratic formula or completing the square. Typically, we're going to use the quadratic formula here. So if you use the quadratic formula, we end up solving x to be negative 2 plus 2 root 5. And now you might be wondering why we don't include the negative here, but because this is a length, so we don't want a negative number. Okay, moving on to the second example, I have a golden rectangle with a side length of 7. They want us to find all possible lengths of the other side. Okay, so that means that 7 could be the longer side, 7 could also be the shorter side. Okay, so I'm going to use my golden ratio, which is what we found in the above example, or in the above exploration. So 1.618 is to 1 as 7 is to x, or 1.618 is to 1 as x is to 7. So depending on whether 7 is the longer or the shorter side. Okay, so if we solve this out, again we can cross multiply. 1.618x is equal to 7, so x is 4.326. Or if I solve here, I end up getting that x is 7 times 1.618. So together that would be 11.326. Okay, so let's explore a little bit of what actually makes a golden rectangle a golden rectangle. So again, I'd like you to pause this and try to walk through this yourself first, and then if you're in the trouble, go ahead and watch what I did. Okay, so we have our rectangle, and again we have a sum of two lengths here, which is really the whole idea behind our golden ratio. So if I find my whole segment length, I find that x plus y must be equal to 1. Right, that's what they told us right here. Now if I solve this equation for y, then y is 1 minus x. The larger rectangle must be similar to my smaller rectangle, so this ratio, this proportion must be true. So if I substitute what I just found into my ratio here to the right, I get 1 over x is equal to x over 1 minus x. Okay, now if I cross multiply and then essentially solve for x, then I will end up with what I wanted, right? So moving down a little bit. Again, what I have here is after cross multiplying, x squared is equal to 1 minus x. So if I move everything to one side, I can again use completing the square or the quadratic formula. Let's use the quadratic formula in this case. So we're just going to plug in. I get negative 1 plus or minus the square root of 1 squared minus 4ac all over 2a. Okay, reducing this, I end up with negative 1 plus root 5 over 2. And again, we're going to ignore the negative for now because this is a length. So if I actually solve this, I end up with the same ratio, which is what I wanted. And that's what makes this special. Similar to how you can get pi with any circle, with any rectangle that has the appropriate ratio of lengths, you can get the same ratio every time. Yeah, that's the idea. Alright, that is it for these notes. Your homework is this worksheet right below. So if you have any questions, let me know. Otherwise, have a fantastic rest of your day.